Have you ever felt that? That weird, invisible pull? You know, the one that feels a little bit like magic when you stick a note on your fridge? Well, today, we're pulling back the curtain on that very force, magnetism.
I mean, really stop and think about that for a second. It's a pretty wild idea, isn't it? An invisible energy that can literally pull something across a table without anyone or anything physically touching it. So how does that work? Let's dive in and figure it out.
Okay, so to get to the bottom of this magic, we have to start at the source. And the source is this, well, it's like an invisible bubble of influence that every single magnet creates all around itself. And here it is, the key to the whole mystery, the magnetic field. This is that invisible area, this bubble of force that radiates out from the magnet. And when the right kind of object wanders into this field, it gets pulled right in. This field is where all the power comes from. But here's the thing. This magnetic field is a little bit picky. It has a very exclusive guest list. It doesn't just pull on everything it sees. So the big question is, who gets an invitation to the magnetic party and who gets left standing outside? And this breaks it down perfectly. On one side, you've got your VIPs, the magnetic objects. The key ingredients here are metals like iron, nickel, and cobalt. These are the materials that get a response from the magnetic field. But on the other side, you've got things like wood or a piece of fabric, and they just don't care. The magnetic field passes right through them like they're not even there. All right, so we know what magnets can affect, but what happens when you bring two magnets close to each other? You might think it'd be chaos, but it's not. Turns out there are some very clear, very predictable rules that they always followed. So the first thing you have to know is that every single magnet has two totally distinct ends. We call them poles. And here's why. If you were to hang a magnet from a string so it could spin freely, one end would always swing around to point north and the other would point south. That's literally where they get their names, the North Pole and the South Pole. So let's do a little experiment in our heads. Imagine you've got two of these magnets right in your hands. First, let's try to bring the two like poles together. So push the North Pole of one magnet towards the North Pole of the other. What do you feel happening? You can almost feel that invisible cushion between them, can't you? There's this resistance. They push away, they repel each other. And that is a fundamental, unbreakable rule of magnetism. Like poles always repel. Okay, now let's flip one of those magnets around. This time, we're bringing a North Pole close to a South Pole, two unlike poles. And what happens? They just snap right together. That's the second great rule in action. Unlike poles attract. It's the classic case of opposites attract. For real. But the rules of attraction aren't the only cool things about magnets. Oh no. They have a few other quirks that are pretty surprising. Let's dig into a couple of their hidden secrets. Okay, check this out. If you take a magnet and you snap it in half, you don't end up with a separate north piece and a separate south piece. Nope. What you get are two brand new, totally complete, smaller magnets, each one with its own north and south pole. And another wild fact, water doesn't stop a magnetic field. You can drop something magnetic into a glass of water, and a strong magnet on the outside of the glass can still pull it right through the water. Pretty cool, huh? So far, we've been talking about magnets you can actually hold in your hand. But now, I want you to zoom out with me. Way out. Because what if I told you that you're standing on the biggest magnet you will ever encounter? That's right. Our planet, Earth, it acts like one massive, incredibly powerful magnet. And this isn't just a fun little comparison. It's a physical fact. It is the entire reason a compass works. That little needle is just lining itself up with our planet's gigantic magnetic field. So why? How is that even possible? Well, it all comes back to those special metals we talked about at the beginning, iron and nickel. Our planet's core is basically a giant, churning, molten ball of those very metals. And all of that movement generates this colossal magnetic field that wraps around our entire planet like an invisible shield. So the very same force that sticks your kid's drawing to the fridge is the same force that guided ancient explorers across oceans and even protects our planet from harmful solar radiation. It really leaves you with a pretty big question to think about, doesn't it? If our whole world is being shaped by this enormous, invisible magnetic field, what other invisible forces are out there? Quietly shaping our universe in ways we're only just starting to understand.